In this video, I'll show you how to use the ggplot2 package to create some graphs. So I'm going to use the tiger data from the previous video again. And again, before you start, you should set your working directory and load this other dplyr package. And then to load the ggplot2 package, I first of all need to install it. And then we can load it using the library function. Once you've installed a package, that's actually just a one-off. You don't need to do that every time, but you do need to use the library function if you want to load it. When I use ggplot2, I like to set the theme of the way the graphs look to a classic theme. So I run this command here, theme with theme_set. But if you like the default theme, you don't need to run this. So first example I'll do is a bar graph, and that's going to use the variable activity ordered that we created last time. So just to remind you what that was, if we look at a table of that variable, we can see grass fodder, 44 people were collecting grass or fodder when they were killed, 11 people were collecting forest products, 8 were fishing, and so on. So if I run this code here, so ggplot is the basic function, and then we use data equals to set the data frame. AES stands for aesthetics, and it's where we define the variables that we're going to plot. In this case, we're going to look at activity ordered, and then geonbar tells ggplot to create a bar graph. And then labs is the labels on the axes, and then this last bit is just going to rotate the labels on the x-axis to 90 degrees. So let's look at the result. So down here in the bottom right corner, we'll see the bar graph. So the activities on the x-axis with the labels rotated 90 degrees, and then the frequencies on the y-axis, and it's ordered from highest frequency to lowest frequency. So a bar graph, useful for displaying frequency data for a categorical variable. What if we have instead a continuous variable? So here's some data on effects of Zika virus, and we have we actually have two continuous variables here, but we're just going to look at one of them. And we can create a frequency table for continuous data if we break the range up into intervals. So in this case, we're going to go from 60 up to 95 in steps of 5. So here's a summary table for the data. So we've got one value between 60 and 65, one between 65 and 70, and so on all the way up to 4 between 90 and 95. So we can display that in a histogram using this piece of code here. Okay, so all ggplot function statements kind of look similar. You specify the data frame, the variables, and then the type of graph. Okay, so that was one continuous variable. What about, and previously we looked at one categorical variable, what if we have two categorical variables? So here's an example data set with two categorical variables, treatment and response for bird malaria. And the treatment can either be, well, let's look at a table so we can see exactly what we're looking at. So it looks like treatment can either be control or egg removal, and the response is either malaria or no malaria. And I can add margins to that table. So this is called a contingency table, sometimes called a cross-tabulation. So one way to graph that kind of data is with a grouped bar graph. So here we have treatment is either control or egg removal, and the response is either malaria or no malaria. And you can see that for the controls, the no malaria is quite a high frequency and malaria is quite low, whereas with egg removal they're about even. Another way to display that is using something called a mosaic plot, and that's a different way of looking at it that takes account of relative frequencies within the two treatment groups for no malaria and malaria. So that was two categorical variables. What about two continuous variables? So let's look at this data. So we've got father ornamentation and son attractiveness for some guppies, and we can display that type of data where we've got two continuous variables using a scatter plot. So here we can see father's ornamentation on the x-axis, son's attractiveness on the y-axis, and the points have a very slight positive correlation there. Lower values of father's ornamentation tend to be associated with lower values of son's attractiveness, whereas higher values of father's ornamentation tend to be associated with higher values of son's attractiveness, so positive correlation. So that's two continuous variables. What about one continuous variable and one categorical variable? So this example has that type of data structure. So I'm going to show you three different ways of looking at this type of data. One is a strip chart. So here we have on the x-axis the categorical variable. So we've got 4 values: Andes, Ethiopia, Tibet, and USA, and on the y-axis hemoglobin concentration. So we can see in the Andes it tends to be a little higher than in the other 3 regions, and the lowest of all is the USA on average. Okay, another way of looking at that is with a violin plot. So violin plot, on one side, this is a picture of the distribution of the values, and then there's the mirror image to create this violin shape, and in the middle, in this case, it's the mean. And then a third way of looking at this type of data is using multiple histograms. So here we've got the different levels of the categorical variable on the y-axis and the hemoglobin concentrations spread out along the x-axis. So 3 different ways of looking at the same data. This next example is looking at time series data. So here we're looking at a line graph where we've got year along the x-axis and then number of new measles cases on the y-axis. So we can see between 1995 and 2005, 2006, the values are kind of bumping along pretty low, and then they shoot up in the late 2000s. And they're jumping all over the place, but they tend to be, at least the higher numbers, a lot higher than they were in the earlier time period. So that's some examples of different ways of displaying data graphically depending on the nature of the variable and how many variables you have.